Turkey is quietly tearing itself open, and no one noticed for decades. Scientists didn't just get a detail wrong, they misunderstood the entire motion of a massive chunk of Earth's crust. What they thought was sliding sideways is actually stretching apart, inch by inch, like the planet is slowly pulled in two. And once you see that rupture, you start noticing them everywhere. To understand why this shocked geologists so badly, picture Earth's crust like a cracked shell floating on something hot and squishy underneath. Those cracked pieces are tectonic plates. They move a few inches per year, which sounds tiny, but over millions of years, it reshapes continents. Turkey sits in one of the most uncomfortable places on Earth, squeezed between three huge plates: Eurasia to the north, Africa to the south, and Arabia pushing in from the southeast like an elbow in a crowded bus. For decades, scientists believe Turkey survived this squeeze by sliding sideways. This type of movement is called a strike-slip fault, which basically means two chunks of land grind past each other like hands rubbing together. Turkey has famous ones, like the North Anatolian Fault, which produces horrible earthquakes. That model felt neat and logical. Pressure comes in, land escapes sideways. Problem solved. Or so everyone thought. But geology doesn't always follow neat models made up by humans. There is a long fracture running beneath salt flats and farmland under central Turkey. It never behaved like the dangerous sideways faults, so it got less attention. Then researchers from Curtin University decided to look closer. And instead of watching earthquakes, they watched lava. Ancient lava. Lava that flowed across the fault thousands of years ago, cooled into solid rock, and later ruptured apart. There are tiny crystals called zircons inside that lava. They're basically nature's stopwatches. Zircons trap radioactive elements that decay in a predictable rate, so scientists can tell exactly when the lava cooled. When they matched lava chunks on opposite sides of the fault and measured how far they drifted apart, the team managed to reconstruct how the fault was moving over thousands of years. It turned out that the fault wasn't sliding sideways at all. It was slowly and steadily pulling apart, just a fraction of an inch per year. That's thinner than a grain of rice, but over geological time, it's massive. This type of fault is called an extensional fault, which means the crust stretches until it thins and breaks. In simple terms, Turkey isn't just being squeezed, it's being torn open. And as if that wasn't dramatic enough, the story gets worse. Other studies show that parts of Turkey's crust aren't just stretching, they're dripping downward into the mantle. When dense chunks of crust get heavy enough, they peel off and sink like blobs of wax in a lava lamp. Scientists call it lithospheric dripping, and this process is basically Earth quietly losing pieces of itself. When that happens, the surface above weakens. The land rises, sinks, fractures, and rearranges. Earthquakes don't always need plates to slam together. Sometimes the ground fails because its support system melts away from below. That's why Turkey's geology now looks less like a solid slab and more like stretched taffy over a fire. Turkey isn't alone with the tectonic drama. Africa is unzipping itself so slowly that no human will ever wake up to a brand new ocean outside their window, yet fast enough that scientists can measure it happening right now. Deep beneath East Africa, the ground stretches and thins. Over millions of years, that constant stretch doesn't just rupture rocks, it rewrites geography. And it can literally create an ocean where solid land once stood. All of this focuses on something called the East African Rift System. This rift runs thousands of miles across places like Ethiopia, Kenya, Tanzania, and Mozambique, and it ranks among the largest rift zones on Earth. A rift zone is where the planet's crust is being pulled apart instead of being squished together. Africa doesn't just have a rift zone, but one of the most extreme versions anywhere, and it's been stretching for tens of millions of years, like a slow-motion disaster movie. And the continent isn't one solid piece anymore. It's splitting into two massive tectonic plates. The Nubian plate sits to the west, the Somalian plate to the east, and they're drifting apart at less than an inch per year, which sounds like a joke until you realize your fingernails grow at about the same speed. But just like in Turkey, this tiny movement adds up over millions of years. Back in 2018, photos of a massive rupture in Kenya caused chaos over the internet, and headlines panicked everyone with the news that Africa was splitting in half. The image looked intense, but it didn't mean the continent snapped overnight like a broken cookie. A much deeper process has been going on for about 25 million years already. And if we could jump another 5 or 10 million years into the future, we'd probably watch the crust stretch so thin that seawater finally rushes in and fills the gap. While Africa is tearing apart vertically, like a slow zipper, India could be splitting in a totally different way, horizontally into two giant layers, each about 60 miles thick, right as it crashes into Eurasia. And this collision is what gave us the Himalayas and the massive Tibetan plateau sitting behind them like a high-altitude backstage area. Everyone agrees on the basics. India has been creeping north for over 60 million years at about the speed your hair grows, slamming into Eurasia and forcing rock upward until it turned into the tallest mountains on Earth. What no one fully agreed on was how Tibet got so insanely high. Some scientists thought India was too buoyant to sink and just slid underneath Eurasia. Others imagined the plate buckling like a sheet of paper pushed into a wall. Then a third idea showed up and changed the vibe completely. This new theory says the Indian plate is delaminating, which means its top layer peels away and props up Tibet. At the same time, the heavier bottom layer sinks into the mantle, the hot semi-molten layer beneath Earth's crust. Scientists can't drill that deep to check, so they followed a clue instead: helium leaking from Tibetan hot springs. Helium-3 is incredibly rare and mostly comes from deep inside Earth, and helium-4 forms closer to the surface. When researchers measured gases from hundreds of springs, they found helium-3 leaking out in northern Tibet. It means that the mantle sits dangerously close to the surface there. Farther south, that signal disappears. So it most definitely means that the plate hasn't fully split yet. But we have earthquake patterns that line up with the same story, so it looks like India isn't just pushing mountains up. It's peeling itself apart from the inside while doing it. All these tectonic processes fit in well with the new massive global stress map. It shows where the planet is holding it together and where it's dangerously close to rupturing. Scientists built it from over 100,000 real stress measurements taken from boreholes, earthquakes, and field tests, which is more than double what we had less than a decade ago. Stress here means the invisible push and pull forces inside Earth's crust, the same forces that quietly load faults for years before one bad day turns into an earthquake. This map doesn't just help explain earthquakes, but also not to mess things up ourselves. If you drill a tunnel, inject carbon underground, or build a geothermal plant without knowing which way the rocks want to snap, you're basically poking a sleeping dragon. Engineers use this stress data to decide how to angle wells and tunnels so they don't accidentally cause failures. Basically, we're finally getting a live dashboard for Earth's breaking points, and that's a big deal when you live on the surface of a restless planet. For a long time, we treated continents like rigid boards floating on soup. Now they look more like stressed muscles, flexing, tearing, healing, and tearing again. It shows that the planet under your feet isn't finished. It's still under construction.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.